Alright, here is the review for verifying, simplifying, and solving trig functions. So for 1a, we have tangent theta, cosecant. I'm going to put everything in terms of sine and cosine. So I'm going to have sine theta over cosine theta. And then cosecant is the same as 1 over sine. Those sines cancel, and you're left with 1 over cosine. Well, 1 over cosine is secant. For part B, I have cosecant squared theta minus cotangent squared theta. And that is really just your Pythagorean identity. That would simplify down to 1. Letter C, again, I'd probably go ahead and write this in terms of sine and cosine. So I'm going to have sine theta times sine theta over cosine. That should be more of a times. And then secant is 1 over cosine. Well, if I multiply everything out, I'm going to end up with sine squared theta over cosine squared theta, which would be tangent squared theta. Letter D, let's put everything in terms of sine and cosine. So we'll leave that alone. Sine theta. Cotangent is cosine over sine. The sines cancel, and I'm left with just cosine theta. E, cosine times tangent. It's going to be the same problem as really the last one. Cosine times sine over cosine. The cosines cancel, and you're left with sine theta. For F, you've got sine theta all over cosine theta tangent theta. So let's go ahead and write that as sine theta. Leave that one alone. I'm going to leave my cosine alone. And if I'd been thinking, I would have realized from the previous problem, cosine theta tangent theta is just sine theta. So I'm not even going to do the work on that one. I'm just going to cross it off. If you want to see the work on that, look at letter E, which is anything divided by itself then is just 1. Alright, on number 2, they're asking us to find the angle measurement. They're actually asking for the degree, so we want to do it in degrees and not radians. So sine of inverse of radical 3 over 2, that is your y coordinate, so that 2a would be 60 degrees, because that's radical 3 over 2, and 120 degrees. So look where your y coordinate is radical 3 over 2. 2b, you're looking for the cosine inverse of negative radical 2 over 2. Well, let's find out where our x coordinate is negative radical 2 over 2, 135 degrees, and 225 degrees. For C, tangent of 0, well, tangent is y over x. That means your y would have to be 0, because 0 divided by anything is 0. So that's happening at 0, at 180, And if we make another rotation, 360 degrees. And D, that's one that you have to think about because they're asking us tangent inverse of negative radical 3. Well, I know it's going to be in quadrant 2 and 4 because it's negative. And it would have to be your y over x. So you have to look and see where y over x would be negative radical 3. It's going to happen at 120 degrees. And at 300 degrees. All right, so on those, all you have to really do is look at your unit circle and figure out where they match up. All right, on number 3, we're going to have to do some verifying. So those are almost like the simplifying, but you're just going to choose one side to work with. All right, let's take a look at this first one. I've got cosecant theta minus sine theta. This is a side I've decided to work with. Cosecant is the same as 1 over sine. And I left sine alone. I'm subtracting fractions. So in order to subtract fractions, you need a common denominator. So I multiplied that by sine over sine. So I'm left with 1 over sine theta minus sine squared theta over sine theta. Well, I've got the same common denominator now, so I combine them, and I got 1 minus sine squared theta over sine theta. Well, that's a Pythagorean identity. 1 minus sine squared theta is really cosine squared theta. Well, cosine squared theta is really just cosine times cosine. So cosine over sine gives me the cotangent, and I still have just that plain old cosine. So out there, you just proved one side is the same as the other. Letter B is really the same problem. It's just starting at the second step. On C, we've got cotangent theta plus 1 quantity squared. So I'm going to go ahead and FOIL that out. Remember, that's actually cotangent theta plus 1 times cotangent theta plus 1, so you need to actually FOIL. And when I do that, I'm going to get cotangent squared theta plus 2 cotangent theta plus 1. Well, if I were to rewrite that as, take that 1 and write it first as 1 plus cotangent squared theta plus 2 cotangent theta. This right here is a Pythagorean identity. 1 plus cotangent is cosecant squared theta. So there, I just proved that one side equals the other. On D, I think the side that I'm going to work with is right over there. So cosecant is just 1 over sine. This one I think is going to be pretty straightforward. And I'm going to leave that as cosine. If you want to, you can put it over 1. I'm going to end up with cosine over sine, which if you work that out is cotangent. All right, on E, I've got tangent squared theta times cosine squared theta. And then I've got over here 1 minus cosine squared theta. Well, on this problem, I decided to work off this side. Um, Tangent can be rewritten as sine squared over cosine squared. I'm going to leave that cosine squared alone, and you're going to cross off the cosine squareds. So now I'm left with just sine squared. Well, I probably would have left it right there because that looks like it's in the simplest form. But if I look at my Pythagorean identities of sine squared plus cosine squared equals 1, I can rearrange that and get sine squared is the same thing as 1 minus cosine squared. So it's verified. All right, let's look at number 4. All right, I just paused to write these down so you guys didn't have to wait for that. On this one, you definitely are going to need a calculator. I'm going to assume that you guys probably can get that first one yourself. Make sure your calculator is in radians, and you just hit second tangent 1.25, and you should get 0.89. 896. Well, that would be in the first quadrant. So that is your 0.896. So that is your first answer right there. Well, it's positive, so it would also be in the third quadrant. That angle that I just marked there would also be 0.89. Halfway around is pi, and then you're going to have to add another 0.896, so take 3.14 plus 0.896. And you get 4.036. And that would be your second answer. For letter B, hit second sine 0.42, and you get 0.43. Well, sine is your y coordinate, so that's where your y's are going to be positive. So those two angles are going to be the same, and that's 0.43. So to go all the way, start at your positive x to here, that's going to be 3.14 minus 0.43. I get 2.71. All right, this one is a negative sign. That means my y's are going to be negative, so it's going to be in those two quadrants. So just hit second sine negative 0.62, and I get negative 0.687, or negative 0.6687. It's negative, so it's going that direction. And those two are going to be the same. So let's get a little bit color-coded here. On that first one, I'm going to start my positive x and end up there. On my second one, start at my positive x and end up there. So the first one is just going to really be, I'll leave that in green 3, not 3. It's almost one whole rotation, so it'd be 2 pi, 6.28 minus 0.62. And we get 5.61. So that is my first answer. The one that I did in black from here to there is just going to be 3.14. And then you traveled another 0.62 radians. So 3.14 plus 0.62, get 3.76. And those are going to be my answers. On the last one, the cosine is 0.28. Well, cosine is positive, and that's your x-coordinate. So it's going to be in those two quadrants. Put it in your calculator. Second cosine, 0.28. And you get 1.28. That's going to be my first quadrant answer. And then I need to travel from the positive x all the way around. It's going to be 6.28 minus 1.28, which is 5. And if you are ever not sure, you can always put them into your calculator and check them. All right. On number 5, that's when we start solving. I'm going to go back to where I have my unit circle. And we'll just solve them right here. Because when you solve, you definitely want to have your unit circle with you. Let's go ahead and erase what we have here. So on 5a, you have 2 cosine theta plus radical 2 equals 0. Well, if I solve for cosine theta, I'm going to get cosine theta equals negative radical 2 over 2. So look where your x-coordinate is negative radical 2 over 2. And that happens at 3 pi over 4 and at 5 pi over 4. So that was 5a. Let's take a second now and do 5b. On that one, if I just divide both sides by 2, I get cosine theta equals 1/2. I'm going to look for where my x-coordinate is 1/2. That happens at pi over 3 and at 5 pi over 3. So those are going to be my two answers for 5b. For 5c, your cotangent, you divide both sides by radical 3 and you get cotangent theta equals 0. Well, I don't like dealing with cotangents, so I'm going to do the reciprocal. And the reciprocal there was going to be 1 over 0. Uh-oh. Remember, that's y over x. That's undefined because we have 0. But that is going to happen at, it's going to be undefined at pi over 2. And you're going to have 0 in the denominator at 3 pi over 2. But it's undefined. There is no real solution on that one. I guess there is, because we're not dealing with the reciprocals. Sorry. All right. Which one are we doing now? 5D. All right, another tangent. So on this one, let's write out the full problem. 5 tangent theta minus 4 equals tangent theta. This one looks complicated, but it's really not that bad. I'm going to subtract tangent theta from both sides. add 4 to both sides, divide by 4. And when you do that, you get tangent theta equals 1. Well, remember, that's y over x has to equal 1. And that happens at pi over 4 and 5 pi over 4. And our last one, e, don't FOIL those out. They're already factored for you. So take each one of those factors and set them equal to 0. And when you do that, you're going to get sine theta equals 1/2 and cosine theta equals 1. Well, let's look at where our y coordinates are 1/2. It happens at pi over 6, 5 pi over 6. So there's 2 answers there. And then where cosine is 1, that's where our x coordinate is 1. It happens at 0. You probably could go ahead and put 2 pi down as well. All right, on number 6. They're asking what quadrants they're positive. Well, cosine is negative. That would be your x coordinate. So cosine is negative in quadrants 2 and 3. And if you don't remember your quadrants, here's 1, 2, 3, and 4. For B, that sine is positive. That's your y coordinates. Sine is positive in 1 and 2. And for letter C, that's tangent. Tangent is y over x. And it's negative. It would be negative in quadrants 2 and 4. All right, enjoy.